Okay, coming back to our topic. To overcome the inefficiencies of asynchronous transmission, multi-beam serial data communication employs the synchronous data transmission mode. In synchronous data transmission, basically no framing is required. The characters do not have a start or stop bit and are sent continuously without space or characters in between. Initially, though, one or two time sync characters can be sent, and thereafter the data characters are sent without any extra bits with some checksums in between for error detection. So, to put it in perspective, if we send a 10 kilobit of data, there is a overhead of only two sync characters and let's say a checksum character. So the overhead here is as low as 0.03%, unlike the asynchronous transmission where we saw that the overhead was as high as 37.5%. Though the issue here is the clock frequency, which must be identical in the transmission and the receiver end. Because if there is even a small difference in the clock frequency, we may well end up with a garbled or a data break. So comes the interesting concept of 1 PPS. Now this requires a separate discussion which we will bring up someday later. Finally, we come to the last significant serial data communication characteristics, that is the transmission medium. Usually a 24 gauge tint copper twisted pair is used on board to reduce the electrical noise. It can be a twisted pair combination coil with a braid shield to protect the signal from the electromagnetic interferences. Also, a foil shield is available to protect it from high frequency noise, and there is a drain wire to terminate the foil shield. A survey tech must remember to solder the drain wire to the DB9 casing. A second shield layer, that is a woven braid, is placed to minimize the low frequency interference and also for the cable's structural integrity. And finally, as we know, it is the grey plastic casing. For any further long distance transmission, the modems are employed. Basically, the RS-232 standards were developed for interface between computer and a modem. But along the way, we started using it to interface between two computers using a simple null modem, which basically is nothing but a cross cable connection. That brought in a concept of DTE, data terminal equipments, and DCE, data communication equipments. We will discuss on that in our forthcoming discussion. The only thing to understand here is that the modem, using multiplexing and phase encoding techniques that convert the serial data bits into multiple tone, basically it is converting the digital signal into an analog signal within the 3 kHz voice bandwidth. And then the data signals are modulated over radio frequencies to be transmitted to long distances. In the last few decades, as I see it, technology has taken the key to efficiency, which has gained a pedestal much higher than hard work, which earlier was the golden standard for efficiency. And thus, a good understanding of the same is pertinent to maintain the efficiency of our systems. And hence, we are in this discussion. Well, before we conclude, a word on the limitation of speed in modems. Modems usually operate in 9600 to 288 kilobaud, but with data compression techniques, the speed has been effectively extended to a baud rate of up to 115.2 kilobaud. Just as a prologue to our next discussion, I came across an interesting statement. The great thing about standard is that there are so many to choose from. This statement was made in reference to fiber optics, but it holds true for electrical interface standards as well. In our forthcoming discussion, we will further elaborate on the much in use standards on survey setup RS-232 and RS-422, its electrical and physical layer specification, conversion from one standard to another standard, and to combine different standards within the same application. So take care, we'll see you around. Bye-bye.